The problem that we are going to discuss today is Tic Tac Toe. The problem appeared in May 21 long challenge and is a difficulty level of easy. There are no prerequisites to solve this problem. The problem statement goes as follows. The problem is based on a popular game known as Tic Tac Toe. I am sure many of you might be already familiar with it. So in this game, we play on a 3x3 grid wherein the player places either a symbol X or the symbol O, and the game continues until a player has 3X or 3O in a row. So, or in a diagonal as well. Now, given the state of the tic-tac-toe board, the question demands that we print 1, 2 or 3 given the following conditions. So, if the position is reachable, that is the given state is reachable in the game and the game is over, that is either it has been drawn or one of the players has won, then we will print the integer 1. If the position is reachable and the game will continue for at least one more move, then we will print the integer 2. And if the given state is not reachable, in that case, we will print the integer 3. So we will be given a 3x3 grid and we have to just print for each test case 1, 2 or 3 depending on these conditions. So for example, I have 3 boards over here with me. For the first board, you can see that this state is reachable and at least one more move can be played. So the answer for this case will be 2, because the state is reachable and at least will continue for one more step, one more move. Whereas for this second board, the answer is going to be 3, because you can see over here that 3x are in a line and also 3 O's are in a line. So this cannot happen in a game of tic-tac-toe, because as soon as one player wins, the game stops over there. So this is not a reachable state. In that case, we print 3. And in this third board, the answer is going to be 1, because the game has finished and the game has been drawn. That is, none of the player won, but the game has been finished. So in that case, we will print 1. So these were some of the examples, but there can be many such possible states, right, of 3x3 grids containing X and O. So we'll be given a snapshot or a current state of the board and we have to just comment whether the answer is 1, 2 or 3. Let's see how to approach the same. The solution approach goes as follows. First, we need to understand some basics about the tic-tac-toe game. So in the any given state that we will be having, there will be some number of X and some number of O's. But because X always begins the game and alternate they place X, O, and so on, the number of X, that let's call it X count, and number of O's, let's call it O count, X count should always be greater than or equal to O count. It can never happen that the number of O's are greater than X. Also, if you observe, this difference cannot be very large, because if you see, the order of placing can be XO, or it can be like XOX and stop somewhere at an X. So it can either be that X count is equal to O count, that is the number of X placed and the number of O's placed are equal, or the number of X placed are number of O's placed plus 1. That is, their difference can be at max 1. The difference can be 1 or 0, because they play alternate and we start with X. This is the first basic thing that you should notice. Also, whenever either of them wins, there is one more condition that you should look at, and that condition is that, let's say the X had begun the game, so X, then somewhere over here O, then again X, then again O, and then again X. So the game will stop at this moment. So if X has won the game and the game has stopped there, then definitely the count of X should be 1 more than the count of O, which you can see in this case is clearly visible. Similarly, if O wins the game, then the board would look something like this. So X will begin, so X, then O, then X, then O, then X, and then O. So in that case, if O ever wins the game, then the count of X on the board must be exactly equal to the count of O, all because they play alternate and X begins the game. So you can see that over here. So these are some basic things that you should know about the tic-tac-toe game, also known as the XO game. Now, these are the basic conditions. If any of these are violated, then you can clearly say that it is an unreachable state. So also in the game of tic-tac-toe, only one player can win, because as soon as the player wins, the game stops over there. The next player cannot make the move. So now we can move to the casework, which can tell us based on the given state whether the answer is going to be 1, 2 or 3. Now, following are the conditions for the answer equals to 3, that is unreachable state. First of all, I have defined two Boolean variables xwin and owin that denote respectively whether the character x or o is present 3 in a row or a column or a diagonal. If yes, then the Boolean variable will be true, or else the Boolean variable will be false. So the name itself is self-explanatory, that is xwin and owin. So first condition is that if both of them are true, so if xwin and owin, then definitely you can see that in this first case the answer is going to be 3, that is unreachable state. Also, if x count is equal to o count, that is the both of the counts are equal, or the x count is equal to o count plus 1, these are the desired values. But if the negative of that, that is if both of them are not true, then in that case also the answer is unreachable, because just now we saw that in a proper game of XO or tic-tac-toe, these conditions must hold true. Any one of them must hold true, right? Sorry, exactly one of them must hold true. So if both of them are false, then definitely the answer is unreachable. Now, the third case is that if x is winning, that is x has 3 in a row somewhere, in a row or a column or a diagonal, but the count of x is not equals to o count plus 1. In that case also it is unreachable, right? Because we just now saw that if x is winning, then the count of x must be exactly 1 more than o. Similarly, for O as well, if O is winning, the count of x must be exactly equal to O. But if that is not the case, then we have an unreachable state. So these are the four broad cases in which the answer is unreachable. If you take pen and paper and try to draw some examples, and if the basics are clear to you, you will get that these are the only four cases in which the answer is unreachable. Now let's see the cases for which the answer is reachable but the game has finished. So the cases for answer equals to 1, that is a reachable state but the game has finished, are very limited. That is, if exactly one of x or o has won the game, or the game has been drawn, then the answer is 1. So there are not many cases, just that we have to check whether x has won or o has won, and we have to ensure that exactly one of them has won, or else the game should be drawn. These are the two cases for answer equals to 1. And because now we have seen the cases for uh, answer equals to 3 and now answer equals to 1, all the remaining cases will go for answer equals to 2. So we can write a simple if else if ladder. So first we'll write an if statement for answer equals to 3, then else if for answer equals to 1, and or else the answer is going to be 2. So the question is pretty much based on casework. So let's now quickly move to the C++ implementation where you will see that only the cases are implemented using if-else statements, and rest all is pretty much easy. So the implementation goes as follows. You can see in my code that first of all I have taken the input for test cases, then for each test case I have taken the input, that is the strings a0, a1, a2, then I have also taken the transpose of the given 3x3 matrix, because I am going to use that for counting the rows and columns, so it will be easy for me. You can ignore this part for now. Now I have two variables x count and o count. So I just iterate in my given matrix A and count the number of x and count the number of o's and increment them respectively in x count and o count. So at the end, I have the total number of x and total number of o's in my matrix. Now I have a check function over here which takes a character as an argument and tells me whether that particular character is present 3 in a row or 3 in a column or 3 in a diagonal. So I check in the rows if it is present. I check if it is present in the columns. So while checking in the columns, I actually make use of the transpose, because in the given original matrix, if I have to check the columns, then it is going to be tough for me. Instead of writing multiple if statements, I decided to take the transpose and check the rows in that. So that is taken care over here. And finally I check the two diagonals. So all these conditions are present or equal to. So you can see over here answer or equal to, answer or equal to, and similarly the same over here as well. So in the end, if the answer is true, I return that. If the answer is false, I return the Boolean value. So this is basically my helper function which tells me whether the character ch is present 3 in a row, 3 in a column, or 3 in a diagonal, any one of them. Further, I have these booleans like xwin and owin. So xwin is nothing but I call the function check with the character x, and for owin I call the function check with the character o. Now once I have these booleans, I have initially defined my answer as 2. So by default I am considering that my answer is 2. Now I will only check if it can be 3 or it can be 1. If it will be, then I will change it to that. So first of all, if x win and o win, that is if both are winning, then definitely it's an unreachable state. Also, if the counts are bad, that is x count equal to o count or x count equal to o count plus 1, if this is not being followed, then also my answer is not reachable. Or if x is winning, that is there are 3 in a row for x, but the count of x is not o count plus 1, in that case also my answer is going to be 3. Similarly for o as well, as discussed in the solution. So these are the only 4 cases for unreachable state that I've coded over here. Now for answer equals to 1, there are only 2 cases, that is if x win plus o win equals to 1, that is exactly one of them is winning, or the game has been drawn, that is x count plus o count equals 9. So if the full board is filled and no one is winning, then definitely the game is draw. So that condition is checked over here. And one additional condition I have checked over here is that for a state to be reachable, the counts must be good. What do I mean by good count? Good count is like x should be either equal to o or it should exceed by 1. So if these are the conditions that are followed, then the answer is going to be 1. And in all remaining cases, by default, I already have my answer as 2. So I don't have to worry. I'll just print the variable as follows, and that's it. My code is completed. So we started by taking the input, took the transpose for calculating purposes, then calculated the total number of O's and total number of X's. Then we have a function which tells us whether there are 3 in a row X or 3 in a row O based on the given character. And then as discussed in the solution, we have our simple 4 plus 2 total 6 cases in which the answer can either be 3 or 1, and in the remaining cases the answer is going to be 2. So that completes our solution. It's pretty much based on casework. Now I would like to tell you guys about competitive programming tutorials that we have at CodeChef that are taken by our educators. So if you are new to programming and want to learn the new concepts like backtracking, binary search, trees, basically everything there is to learn in CP, you can head over here to this section CP tutorials and do these courses for free. And also if you want even more structured content, you can opt for the plus subscription on Unacademy, where you can use my referral code Darshan25 to get instant 10% discount.